Good morning, students. Today we'll see the design of the gravity dam. So let us first understand what do you mean by gravity dam. Actually, the gravity dam is defined as the structure which is designed in such a way that its own weight resists the external forces. Such type of gravity dam is constructed by the concrete or masonry. So its own weight acts as a stabilizing force. If you'll see the typical cross section, it will be like this. This part is called toe of the dam, and this is called the heel of the dam. This is the base of the dam, this is upstream, and this is downstream. If you'll stand over here and if you'll see the upside, then that part is called the upstream, and if you'll stand over here and see the downside, then this part is called the downstream. Here the water is retained, the water is ponded over here. Suppose this height is h, the height of the water which is stagnant by the massive structure of the dam, and here some tailwater is also present over here. And basically the most of the structure, the drainage gallery is provided to reduce the uplift pressure. The structure may be like this, it may be different, but now we'll use this type of structure. Now let us see the forces acting on the gravity dam. So let's see the forces acting on the gravity dam. There are so many forces which may be stabilizing force or which may be unstabilizing force. That means some forces which are balancing and some force also which are unbalancing. So let us see one by one. The first force which is acting on the dam, which you are looking, the first one is the water pressure. Second one is the uplift pressure. The uplift pressure is nothing but the water pressure which is acting in the upward direction through the foundation of the dam. We know that the soil has three-phase system. Some pores maybe exist also in the soil, also in the foundation materials. Therefore, the water exists in that pores and which will act in the upward direction. So this is called the uplift pressure. Third one is the pressure due to the earthquake forces. Pressure due to earthquake force. Fourth one is silt pressure. Silt is what? Everyone is aware of that. Whenever the river is flowing, it erodes the soil from the riverbed or cuts from the side slope of the river, and which mix with the water, and it is in the form of suspended particles. When water reaches to the dam and the water stills over there, therefore the effect of gravity, it settles down to the base of the dam, also at the face of the dam. So it also exerts some sort of pressure, which is called the silt pressure. The fifth one is the wave pressure. The wave is generated due to the water with the effect of wind. Sixth one is ice pressure. And the seventh one is, this is the last one, this is the stabilizing force. The stabilizing force is the weight of the dam. So we'll see one by one. So let us start with the water pressure. The first one is the water pressure. So we'll see first the sketch and we'll try to understand. So here is the sketch of the dam and the water is written over here. This is the symbol of water. Suppose this height is H, capital H. So the pressure variation will be linear. As we go downward inside the water pressure increases and its variation will be linear like this. Here the pressure is 0. Here the pressure is this much, gamma W into H. Here is the gamma W is unit weight of water. I think everybody is aware of that. If we'll take the arbitrary height, suppose this height is Z, therefore pressure over here will be gamma W into Z. Likewise, if the tailwater is present in the downstream side, this is upstream, this is downstream. Suppose water is present over here, then suppose this height is H dash, then this from at the bottom the pressure will be gamma W into H dash. This will act in the horizontal direction. The intensity will be half into gamma W into H dash square. And here the pressure intensity will be half into gamma W into H square. This is calculated by the area of the pressure diagram, and this height will be H upon 3 and this height will be H dash upon 3. And here this water will act in the downward direction. So this water pressure is PV. So this is all about the water pressure. Here the water is impounded over here. This will act in the horizontal direction. In this direction, the pressure variation will be linear. The intensity of the pressure or total pressure, that is equal to the area of this pressure diagram, that is equal to half, this is the triangular shape, therefore half into gamma w into h into h, that is equal to half into gamma w into h square. Likewise we have calculated over here in the downstream side, that is called the tail water. This is called the tail water. Next we'll see the uplift pressure. Uplift pressure. This pressure is nothing but the water seeping through the pores and the cracks and the features of the foundation materials. The water seeping through the dam body. Then this water will exert the pressure in the upward direction. The research had been made by the United States Bureau of Reclamation, in short we can say USBR. The recommendation, the pressure variation is given by the USBR recommendation. So let us first draw the sketch. This is the upstream, this is the downstream. This height is h, and this is the water pressure, and this is the tail water pressure. This height is h dash, and this, the intensity of pressure over here is gamma w into h dash, here gamma w into h. As per the recommendation of USBR, the uplift pressure, here the pressure will be, the pressure intensity equal to the pressure of the water impounded, or which we can say the retained in the back side of the dam. So the intensity to the pressure or the uplift pressure is gamma w into h at the heel, and toe it will be gamma w into h dash. This is the variation of the uplift water pressure in the upward direction. This is recommended by USBR. This pressure diagram, in the absence of, there are two conditions of the uplift pressure. First one is the absence of the drainage gallery. These conditions exist for the absence of the drainage gallery. So here, in the absence of drainage gallery, there is no drainage gallery. And suppose if drainage gallery is present, one second, we'll draw the sketch of the gravity dam. If the drainage gallery is present over here, so the pressure variation will be like this. Here this is equal to gamma w into h, here this is equal to gamma w into h dash, this is h dash, tail water, and the pressure variation will be like this. This will be not linear exactly. Up to drainage gallery, this will be like this, and from the drainage gallery up to the toe, the variation will be like this. Here the intensity of pressure will be gamma W into H dash plus 1/3 of gamma W, gamma W into H minus gamma W into H dash. This is the ordinate at the drainage gallery. Thank you, students.